Hello and welcome to yet another video, and thank you also for stopping by on my channel. In this discussion, we'll be looking at servers, web servers in particular, how to transfer a file to a server, how to install NGINX, how to set up a domain name, how to perform redirections using NGINX, how to return error pages, and lastly, we're going to take a look at how to install NGINX with Puppet. In my previous video, I showed you how to generate SSH key pairs and also how to connect to your servers. So this is just like a continuation of the previous video. I'll encourage you to watch the previous video on SSH because it gives you a better understanding of the web server project. So if you are yet to do your SSH tags, just go to the video, get instructions and guidelines, and get your project done before you come to web servers. So let's dive right into the video. But if you're yet to subscribe to the channel, you're going to miss out on a whole lot because I'll be creating a playlist of system engineering DevOps projects. So before we begin, let's look at what servers are. So a simple definition of a server is just it's a computer program or a physical machine that provides services or resources to other computers or devices on the network. Now, one thing I try to do in this channel is that after giving you a technical definition, I'll also try to make illustrations and give you scenarios that helps to cement your understanding of the concept. So if you find this difficult to understand, if you find these technical jargons difficult to understand, don't worry. I'll also at the end of my discussion, I'm going to give an illustration that might help you understand the concept. Now, the reason why I'm doing this is because I just want to lay a good foundation so that when I begin to solve exercises, the whole thing just becomes clear to you and also broadens your knowledge on whatever you have learned already. So let's continue with the definitions. So So what's a physical server? Remember, we can have a server as a physical server or a software. So in terms of a physical server, I have said that a physical server is just a computer system that is designed and built to provide a specific set of services. So if I was designed to provide just a particular kind of service, you can refer to me as a physical server. So such services can include storing and saving files. You can also host websites or applications. So I can design a computer system that can store files for me or that can send me files. Or I can design a computer system that can be hosting websites or applications. So when you do that, you can refer to that as a physical server. And I can also design a computer system that can be running other software. So all these are just what a physical server or the functions of a physical server. So I also additionally I said physical servers are machines that can be located in a data center. So in case you wonder where these physical servers are, they are always located in a data centers or a premises within an organization. So if you have an organization or a company, you've programmed a specific computer to be able to carry out these services that we've mentioned earlier above, you can refer to that as a physical server. But most times, physical servers are located in data centers. So a physical server typically consists of a motherboard. So what are the features of a physical server? We said it should have a motherboard to carry out processing. It should have a CPU, it should have a memory, it should have storage such as hard drives, and it should also have network interfaces and other components. So these are some of the components that a physical server should have. And we say the hardware components work together to provide the necessary resources for the server to perform its designated tasks. So if I'm too fast with my definitions, you can always pause the video and just get what information you want to get. So I'm just trying to keep the video short and simple because this is going to take a whole lot of exercises to be done. All right, that was just by the way. So in contrast to virtual servers, that is physical servers. We have physical servers and we can also have them as softwares. So in contrast to visual servers, which run on top of a host machine, physical servers are dedicated machines that run in a specific operating system. So unlike your virtual servers um, that just are just there like softwares, physical servers, they are dedicated machines that can run in a specific operating system like Linux, Unix, and Windows, and all of that. And they are capable of handling high loads of traffic and demanding workloads. So next thing we said, essentially a server is like a central hub that other devices connect to in order to access resources or services. So when other devices try to connect to a particular device, that is designed to perform a specific function, you can refer to that as a server. Now let's look at what um, servers, examples of servers. So there are so many examples of servers, but let's just make it concise. We said the first example of a server here is a web server. So a web server is just an example of a server. Remember, a server is just a software that is dedicated or programmed to run a specific set of instructions or operations. So if that server has been designed, to serve static content such as HTML files, JavaScript files, you can refer to that program as a web server. So a web server is just a computer program or a software that delivers web pages to you, that delivers web pages or static contents to a client over the internet. How do they deliver these web pages? They do it over the internet. So we said when a particular server is being programmed to serve static content like HTML or JavaScript, you refer to them as a web server. So when I open a browser address and I type, so this is just what happens. So when you type on your web address in your browser, your computer sends a request to the web server. So open your web address to type a page in it. What happens is that your computer will send a request. So in the context of request, we refer to that as a get. The verb to use is get. So in case you've come across HTTP requests and verbs, you say when you're trying to browse or trying to retrieve information, you say get. So when you open a browser and you try to browse, all you're trying to do is just to get a request from the web server hosting that website. So when you type google.com or youtube.com, what you're trying to do is to get requests from the web server that is hosting that website. So that web server now sends the web page back to your computer for display. So when I browse youtube.com or github.com or alx.com or anything, what I'm trying to do is I'm trying to get information from the web server, and then the web server will now respond and give me or serve me that web page I'm trying to request. So that's what a web server does. The next type of server we have is a file server. And we say a file server is just a computer or a storage device that will store files and folder that can be accessed. So this is just going to store files or folders for you. So example is a company might have a file server that stores all its employees' files, allowing authorized employees to have access and modify them. So when you have a company, for example, you can create a file server for that to be able to store information and data of its employee. So that kind of a server, it's called a file server. Another kind of server we are going to look at is an email server. So email servers is just or are just computer programs that manages email messages and allows users to send and receive email over a network. So when you open your Gmail or your Yahoo Mail or Hotmail or whatever mail you open, there's a server that is dedicated just to handle your email requests, and that server is known as an email server. So, like I said, if you don't understand these technical terms or jargons I'm saying, I'll try to make illustrations and cite examples that can help solidify your understanding. So, we said when you send an email, your email program sends it to your email server, which then sends it to the recipient email server for delivery. So, when I try to send a mail to you, that mail first of all goes to my it goes to my email server. Then my email server now sends it to the person I want to forward that mail to. So when a program or software is designed to handle such services, we refer to it as an email server. So what of a database server? So a database server is just a computer program that stores and manages data in a database. So if the program is just to handle data that is stored in the database, that server that is programmed to do that, you refer to that server as a database server. So these are just easy terms. Depending on on the operation they are handling, that's how you name them. So if they're handling files, you refer to them as file servers. If they're going to handle website, you refer to them as web servers. If they're handling data, you say they are database or database servers. So for example, we said an online retailer might use a database server to store customer and other information. So if you want to store information about your clients, about your customers, you can do that using a database server. Now, lastly, the last type of server we are going to look at before we go into our exercises is the game server. So, a game server is just a computer program that hosts a multiplayer game. So, if for example I want to play a game like chess online, um, so this game server is going to allow players to connect to them and play together over the internet. So, how do we play multiple game players? Like FIFA, PS, and all the rest. So all you need to do is just the game server will host that particular game so that everybody can connect, or those that want to play the game can connect over the internet and they'll be able to play that game. So that's why that's how multiple player is possible. So for example, a player might want to connect to Minecraft server in order to play with friends in a shared world. So that's just basically what we've done. Now, the next thing we're going to look at is examples of web servers. So there are so many web servers out there. Remember, a web server is just a software serving you static files. So when or static pages like HTML and CSS. So there are several types of web server out there, but let's just restrict our examples to just six of them. We say we have Apache, um, HTTP server, we have Nginx. Our focus is going to be on Nginx. So we have Microsoft Internet Information Services, or you refer to them as IIS. We have Lightspeed, we have Kunikon, and we have Kadi. So all these are just examples of web servers. There are several web servers out there, but our focus for this video is going to be on Nginx. So in summary, these are some of the essential concepts of servers, but there's more to learn about this powerful tool. I hope this helps you get started. So there's so much to learn about web servers, but basically what all I've discussed in this video is just to provide a guide for you to be able to carry out your exercises, and not just to carry out your exercises, but also to give you to broaden your knowledge on these concepts. because you're going to be building on this concept in system engineering, DevOps, to be able to carry out your portfolio project. So at the end of your sprint, you are going to be carrying out your portfolio project where you'll be building softwares or programs or applications to perform different tasks. So the knowledge of this just helps you um, get your project done easily. So this is not just about solving exercises, it's about general knowledge entirely to help you become very useful software engineers out there. Now, let me just give an illustration for those that don't understand the technical aspect of what we've done. We said um, we have servers. Now, a server can be like a restaurant. So, restaurant. Yeah, a restaurant. Server can be like a restaurant. A restaurant must have a name. So every restaurant has a unique name. Unique name. And we said that unique name is known as the domain name. So remember we say a restaurant is like a server, and every server or restaurant must have a unique name, which is the domain name. Now we said inside a restaurant must have a menu or should have a menu or mandatory that they have menus, and this menu just contains, so the menu contains different options. So we said different options that are available to the customers. So menu should contain different options available to customers. So you can have different menus available to the customers. So in the same way, a web server can host various web pages so that users can access. So a web server can host several web pages or different web pages that users can or clients can access. So each web page will correspond to a specific dish or content in the menu. So you can have different dishes in the menu. So in the context of servers, you can also have different kind of servers in you can have different kind of pages in the server. So now let's look at ingredients. So we said we can compare ingredients to like in a restaurant, each dish requires specific ingredients to make. So you can similarly in a web page, it consists of files. So we say ingredients are like specific specific ingredients. So you have specific ingredients to be prepared, to be made or prepared. So we can in a web server we can have different kind of web pages also. So we said we can have like files, we can have HTML files, we can have CSS files, we can have JavaScript files, and you can also have images and so on and so forth. You can have videos, you can have yeah, and a whole lot. So you can have this as your ingredient, like in a restaurant where you have different ingredients to prepare a certain meal. So in this restaurant you must have chef. So your chef, their function there is just so you can refer to the chef as the web server. Now this is the web server. So the chef is the web server. So the chef in a restaurant prepares the dishes according to the customer's order. So we said this chef, what do? They prepare dishes according to customer's order. So if I order for chicken, the chef is supposed to prepare um, the ingredients that are necessary just to make my chicken more palatable. So this is exactly what the web server does. Um, Customers order. Now, in a web server like Apache or Nginx, so what they do is just to prepare your web pages to you according to how you've requested them, so that you can be able to retrieve them or be able to display them. So what they do is just to handle requests, they handle requests. Um, they also they'll handle requests, retrieve what information you want, and what they do is to assemble. They also assemble. So just the process of just getting the page that you have requested to you. And lastly, what they do is to save. So first of all, they handle your request, retrieve whatever information you have requested for, assemble it and serve you. So if I've ordered for chicken, they get my request, retrieve whatever ingredient they want from the kitchen, assemble it into preparing a very good meal, and then serve me what I have ordered for. So exactly the same thing that your web server does technically. So Apache and Nginx, those kind of web servers, all they do is just to handle such requests. So now let's look at the waiters. So we said we can refer to the waiters as protocols like SSH and the rest protocol or a set of instructions. So the waiters in the restaurant, they are to communicate between the customers and the kitchen. So they are just there, they communicate between and the kitchen. So when I have an order to place, I just pass it to the waiters. They take my request to the chef, and the chef is going to receive that request, retrieve whatever needs to be retrieved, assemble them, prepare it, and serve me. So the waiters now communicate this back to me, and so that's the whole process of what web servers or server what they do. And so we said in technically what the protocol they use to do this can be like HTTP, so HTTPS, Hypertext Transfer Protocol. We said they use such protocols to be able to facilitate communication between the user and the web server. So, what this protocol is all about is that this is the means of getting those web pages to me is through either HTTP or HTTPS, whichever it is. This is just to facilitate. So it facilitates communication, communication, communication. Yeah, between the user. You can refer to the user as the client and the browser and the web server. So basically, I've tried to make this as easy as it can get. Technically speaking, if you don't understand what web servers are, with these illustrations, I believe you understood quite a lot. So now let's get into some exercises. We can create a directory. So I'll cd into ALS system engineering, and I can make a directory, and the name of the directory is 0x0c web server. So I'll seed into it and just create a readme. Let 0c create a readme. Let me just use cat simple readme. This should be web server. Okay, yeah, anything would do. Control C and ls. I have my readme. I'll go back to the project and let's see what the project. So let's just create the name of the file. Um, just touch it first. Okay, we now have our files ready. Now let's see what this task requires of us. So we are going to look at how to transfer a file to a server. Remember, if your server is working, you should ensure that your server is working. It says write a bash script that transfers a file from a client to a server. So your client can be your sandbox or whatever device you're using, and then these are the requirements for you to transfer a file to your server. These are the requirements that have been given to you. It says the part of the file to be transferred must be there. Your bash script is supposed to accept four parameters. The first parameter is the path to the file. The second parameter is the IP of the server we want to transfer the file to. And then the second name must be the third requirement is the username. The username must use the SCP. So SCP just means SCP just means secure copy. So when you want to copy securely, you use SCP. So this command just copies files securely, because when you try to copy a file from your local computer to a server, this file may be intercepted by all those hackers and the rest. So they'll be able to get the details of your file, the content of your file. So you do it securely by copying it and using SCP. So that's why we're using SSH, because we have like a quite high security for what's it called, executions and other operations we want to carry out. So we said the part of the SSH key that SCP will use. So we are accepting four things. The first thing is the path. The second one is the username. Third being the IP address. Now the path of the file to be transferred. So this is what it means. So we have four parameters. The first being the path. The file we want to copy, where is it located? So we said location of file. So you have to specify the location of the file. The second thing we need to do is the IP address of the server we want to transfer the file to. So we can see IP address. So IP address of the server. The next thing we want to look at is the username SCP should use. So we say username. So you have to specify your username. And lastly, we want to look at the path to this SSH private key. Your SSH private key, where is it stored? So we say location of your private key. Now I'll try to break this down. So we're supposed to write a script that will be able to handle and accept four parameters. Now if the person trying to copy these files, if these four parameters are not there, so if I want to copy a file, so let's say I have this file, like we've seen, I have this file called zero transfer and readme, but they are in my sandbox. If I want to get them into my web server, how do I copy them, or how do I transfer them into the web server? So we're going to write the command to do that, but the telling us that, okay, if I don't enter four parameters, let my script display this error message. So my script is supposed to tell me how I'm going to use the command, and it's going to display this command. It's saying usage, maybe we want to transfer 0 file, and then it will ask you the path to the file, your IP address, your username, and the path to the SSH key. So if I enter less than four parameters, maybe I enter only two parameters while writing my command, this is what is going to pop or prompt. This is what is going to be displayed. It's going to show me how to use my, maybe for example, I'm trying to recharge my phone and I enter a wrong pin. So it's going to, by default, the network is supposed to tell me, okay, click this to recharge, click this to borrow airtime, or click this to check your balance. So this is what we are trying to do here. So in case I don't enter four parameters, my script is supposed to display this for me and show me how to do this. So other requirement is that I'm going to copy this file into the root, and then I must also disable strict host key checking. So there's what we call strict host key checking. So we are going to disable this, and we ensure that we copy our files into the root. So we want to write a script to check if this arguments that have been entered by the user is up to 4. So we are going to use an if statement to do that. So this is about shell scripting. So if you can't remember your if statement in your shell scripting, I'll try to explain it to you as best as I can. So this is what we're going to do. Just veer into our file. And we remember we said in our previous video, we said there's an advantage of using the shebang user bin environment bash instead of the shebang bin bash. One of the most important reason for doing that is that if the interpreter you want to use in interpreting your or reading your shell script is not located in the bin directory, your script will not run. This is because you have different system configurations, like for Linux, um, Unix, and Windows. They have different locations where their bash interpreter is located. So it's always good to go to the, let's start our script. It's always good to go to the user directory, go to the bin environment there, and use the bash script to interpret your script. So that's the advantage of using um, that. So whether your bash script is not located in the bin directory, your script is going to run because you've extended your search towards the user environment. So now the second line of our script is supposed to be a comment, because we are going to check for parameters for transferring the file. We can just say checking for command line parameters or command line argument, whichever it is. So this is just a comment. That must not necessarily be checking for command line argument. So you can just use your own comment. So like I said, we're going to use an if statement to do this. We can say if, then with our bracket we set a variable, and we say if the number of arguments entered is less than 4. Yeah, we remember why it's 4. So if the argument that the user enters is maybe enter only the IP address, the location of the private key, but did not specify the name of the file, that's like 3 arguments. So if the argument is less than 4, what should we do with that? We can now say then, remember the content to display is echo So you can say echo. So we say echo. Now you can get the comment here just to save time. So this is how you display it. We want to display this. So the echo just displays our content for us. Go back to the script and paste that there. So it's going to display this if the number of arguments that you have entered is less than 4. And let's end that quotation. Go to the next line. So after displaying that, what should it do? We say you can exit. Remember, in programming, 1 means error and 0 means successful. So in programming, you said, so 0 represents, 0 is a success, while 1 represents errors. So that's why we say exit at 1. So we end our if statement. Now let's assign variables to um, our argument. So we can put a comment here and say assigning parameters. Yeah, parameters to variables. So let's just use variables. Let's assign parameters to the variables, and we say the first variable is the path to the file. Remember the location of the file. This file you want to transfer, where is it located? So refer to that as the path to file. You can use whatever variable you want. I can say let it be the first argument and represent that with $1. Now for the next argument, we are going to give our IP address, and our IP address, let's save it as the second variable. Now the third variable should be username. What's your username? You have to specify your username. Let's assign that to the third variable. Now you have to specify your private key. Where is it located? So we say path to SSH key. So this just directs the computer to where your private key is. So let's call that the fourth argument. So let me go back to the question. The question says you must disable strict host key checking. So you must disable. So when we are trying to transfer a file, we are supposed to turn off strict host key checking so that so many necessary checks will not be going on that can hinder us from transferring our files. The essence is just to transfer our file from probably locally to remote server somewhere. So we say let's disable strict host key checking, and to do that you can just set your strict host key checking to no. So you can set it to no. So let's give a comment and say okay, um disabling this. So I can say disabling, if that is correct. This doesn't look correct, but though let's leave it. Disabling strict host key checking. Yeah, so let's disable that. So to do that we can say scp for the command for secure copy. Our strict host key checking is -o. So the flag -o just tells us this strict host key checking. So let's try to disable that. We can say strict host key, capital H, camel. I think it's like the camel way of writing. Host key. So every word begins, or every word begins with a capital. So we said key checking. Let's make that no. We can say equals to no. So it shouldn't do any strict key hosting. Minus I just tells us the identity file we want to use to log in. Where is it located? So we can put that in quotations and say this is going to be the variable called path path to key to SSH key. So this is the path to your public private key. Now let's put our variable and say this is going to be the path to the file we want to copy. So we can say path to file. Now lastly, we are going to specify our username. We can say username, assign a variable to that, and say username at our IP address. So our username, our variable IP address, and the question says you should ensure that it copies it to the root directory or the home directory. So we have disabled strict host key checking. We are ensuring that we want to copy this to our what's it called, home directory. So that's what I'm trying to do. So I'll just copy this into my home directory and end my quotations. Okay, this looks good, but let's try to make this fancy. So what if the output or the result of carrying out this command is was successful or not? Let's try to make it interesting. So let's use an if statement to do that. So I can just say um, checking if the file transfer was successful or not. So if the file transfer, maybe I'm trying to send someone money or transfer funds. What if the fund I tried to transfer was not successful? Yeah, you get a message and saying that says maybe the your transaction was not successful. That's the same thing we are trying to implement here. So if I want to copy a file from my local machine to my remote server and the number of argument is not up to 4, then the command is going to prompt you that this is how you use it. Please tell me the file you want to transfer, tell me the part of the file, give me your IP address, tell me your username, and tell me where your SSH key is. So the computer is going to ask you, please, this is how we use it. Tell me the file you want to transfer. Tell me where the file is located. Give me your IP address. Tell me your username. Then show me the path to the key. Then I'll be able to transfer your key, the file for you. And then what if that transfer was not successful? This is what we're trying to do. We're trying to make it interesting by saying, okay, if this file is not transfer successful, remember I said, so we'll just put this in bracket and say, if the outcome of the file, whatever the outcome is, EQ means equal to 0, equal to, so EQ will mean equal to in bash scripting. So if the output of our transaction is equal to 0, remember I said 0 means success. Yeah, I said. So 0 means success. So if the output, when we run a command and the output is a success, then we can now say, if that output is a success, then we can say you should echo. So we can say file was transferred. So whatever you want to echo, you can echo that file was transferred successfully. So I'll just do this. This is just to spice things up. So file was transferred successfully. So what if the file was or else? So we can use an S and say else. If that file was not transferred successfully, you can now echo um we can now say file transfer was, let's see what we can read. File transfer was not, yeah, file transfer failed. That's okay. So we said if the file was not transferred successfully, we can now say, oh, the file transfer was has failed. So something like that, just to make things interesting. So I think I've seen an error here because I did not close my quotation. Okay, this looks good. All right, we can now save and exit. Now we can see that we have our files, and next thing, because this is a script, this is a shell script, we need to make it executable so that the computer can run our codes for us. And to do that, we can change the mode so that users can execute, and the name of our file is zero transfer. And when we ls discover that our file is now executable. Okay, git, let's add all these files we've created. We say git add, git commit. What am I going to say? Okay, how to um transfer files to server. Okay, this works fine, and then I can git push, and let me check my code. So let's check our code and see if that was okay. All right, it says congratulations. Okay, everything is fine then. All right, let's see if we can do the next task. So because this video is going to be a very long one because we have so many exercises to do, I'm going to break it into two parts so that it doesn't get boring, because this is not Netflix. It's not about the project, it's about you getting the required knowledge and skill for you to become a software engineer at the end of the program. So it's not about the green checkers or whatever is correct or whatever is not correct. Understanding just helps you become creative and confident in whatever you're doing. So that's what I'm trying to do. So those of you that are going to criticize me for showing you how to do the project, no, that's not my goal. I believe with the one or two things I'm trying to do, someone gets idea or inspiration to be able to carry out other projects themselves. So that's my aim. All right, let's go to task one. Task one says you should install NGINX web server. Now, for us to install NGINX, we need to be in our web server to be able to install NGINX. Remember, NGINX is just an example of a web server that can serve static web pages over the internet. So for us to install NGINX, we are not going to do that installation on our sandbox. We are going to connect to our web server so that we can install it. Now, if you've not watched the previous video on SSH and you don't know how to connect to your web server, so what I'll do, I'll just cd into yeah, let me cd backwards, go into the SSH directory. That should be 0b, and our ls. You discover that I have a file that contains this code. So let me just vi for those of you that have not done this. So I vi into my web. So just create a file. So instead of logging into your servers and typing commands all the time, you can just gather those commands and just put in a separate file, and you can call that file web01, and let's see the content of it. So this is what I just wrote in my web01. Set number. So I just, so most times people, so many of you will be getting permission denied. So this just creates another means of connecting to your server using the eval agent. So you can come in as the SSH agent. So all you do is just do eval dollar and then put your um, authorization as an SSH agent, then the name of the file where your private key is. If it's not in your root directory, you don't need to write this. If it's somewhere in your ALS system engineering or 0x0C, wherever your private key is, specify that part wherever it's located. So mine is located in the root directory under a hidden folder called .ssh, and the name of my private key is called school. So just use SSH. So I'm going to add this command, just add that private key into your server. So now I'm going to say SSH Ubuntu and my server name. Those of you, my IP address. This is where my IP address is in case you want to ask where I got the IP address from. So you can get your IP addresses from your project when you request for a new one. So requesting for a new server is like destroying your sandbox. Whatever is present in your server will be destroyed. So don't always ask for a new server if you encounter little challenges. Try to fix it. Alright. So that's where I got my what's it called IP address from. So this is the command to do that. So just write all this in the script. Now let me save and exit. I'll just copy the script into the other 0x0 web server directory. And to do that, I'll just say cp-r. The name of the file I want to copy is web 01. I want to take it to a directory called 0x0c, and yeah, okay. Yeah, I'll take it to ALX first, sorry. ALS system engineering. Then I can take it to 0x0c. Alright, I just copied this file. So if you can copy it like this, if you can copy like that, just veer into the file again. Yeah, let me just make things simple because this is where the challenge comes from. So if you can't copy that way, just copy manually. Those of you that like to copy manually, so just copy manually. And now let's go back to our web server, which is cd 0x0c. Now when you ls, you discover that we have a file called web01. So for me to access my web01, all I need to do is to execute it. I'll just say web01. Now it will ask me for my passphrase. My passphrase is according to the exercises, the requirement says Betty. So whatever your passphrase is, you can log into your server. So you right here, I'm in my server. The server name is Ubuntu Web01. So if you successfully done this, you can clear your screen. And now, how do we install NGINX? Yeah, the command to do that is, yeah, but before you install any package in your web server, it's always good practice for you to update your packages before you make any installations. So as good software engineers, before you install any package, ensure that you update your packages before you install any new one. So to do that, because we want to have um, higher privileges, we use the sudo command, and we can say apt. You can use get is just the old fashioned way of downloading a package. You can use apt minus get, or you can use apt get, whichever you feel comfortable using. They are still going to download it for you or update it for you. So say apt get update. So this is just going to update my packages for me. It's always good you update your packages. So it says right there that packages have been installed. Okay, let me clear my screen. Then the next command for me to do is to install NGINX. That's the web server we're going to be using for the project. It's called NGINX. So to do that, we use super privileges and we say apt get. Then we can say install whatever we want to install. Now, instead of typing yes all the time, you can use the -y. So whenever you want to download something and it asks you, do you really want to download this? So instead of going to the stress of typing yes, you can just include that flag here and say yes, whatever is going to be, download NGX for me. All right, let's run that command and we'll be downloading NGINX. Yeah, we've successfully installed NGINX. We'll clear our screen and check the status of NGINX. I think it should be sudo service. So let's use the service command. Service yeah, NGINX. Yeah, let's check the status of our install. So you can see right here that NGINX is actively running. Okay, Ctrl C, Ctrl C. Now let's clear our screen. Now remember we learned how to transfer a file in tax 0. Let's practicalize that. So let's not just do projects, let's put that into practice. So you can see right here that there's nothing in my web server, no files. Now let's go back to our sandbox and see how we can transfer a file locally to a remote server. So this is your web server remotely. Let's go back to a sandbox. Let's get a sandbox. So I've gotten another sandbox. So if you can see, I have a sandbox and I have a web server. So this is my web server ls. There's nothing there now, but this is my sandbox ls. I have so many things there. So I'll just go back into my ALS system engineering project 0x0c web server, and I'll clear my screen to make things simple. Then when I ls, you discover that I have this file called transfer file and a readme and just a way of accessing my web 01. Yeah, a moment ago we learned how to use the secure copy. So if you want to transfer a file, you need 4 parameters to be able to successfully do that. The first parameter is the file you want to transfer. Where is it located? What's your IP address? The username for your connection. What's your username? And then the path to the SSH private key. Show us. So when you successfully provide these 4 parameters, you can be able to copy a file from um, your sandbox or your remote or your local machine to your web server. So this is my web server. Let me ls again. There's nothing there. I'll come to my sandbox and let's try to practicalize the command to copy a file. So the command is you say scp -o just to tell us that, okay, remember we say we are supposed to deny strict host key checking, and we'll do that by saying strict host key checking. You turn it off so that it doesn't interrupt the process, and we said no, we don't want to use strict host key checking. And the next thing is remember we said the name of the file we want to transfer for this exercise is 0 transfer file. So if you have files in your sandbox and you want to move them to your web servers, this is how you do them. This is how you do it, sorry. You now specify the name of the file. If the file is located in a different repository or directory, you just specify the name of the directory and the name of the file. But since the file we want to copy is in the same directory that we are, we can just go ahead and write the name of the file. And the next thing we need to do is to specify where our private key is located, and we say show us your identity key, and the identity key for this task for my own is located in the home directory, um, in a hidden directory called ssh, and the name of that file is cool because that's the file that contains my private key. And the next thing I'm supposed to provide for the computer is my username. Now you're wondering what my username is. I can just go back to the project and you'll see that my username is here. So that's your username, and then I'll get my IP address. So your username is Ubuntu and my IP address is this. So I just get it and provide that. And I said username Ubuntu at what's my IP address. I specify that. Then the next thing I'm supposed to do, remember the question said you should copy it to the home directory. So we're going to copy this file to the home directory. It says you should transfer the file to the home directory. Okay. So to do that, you just specify and say home, and then you end your quotations. Okay. So we've provided four parameters. The first parameter was the name of the file. The second parameter was the location of the file. The third parameter was our username, and the fourth parameter is our IP address. So let's run the command. Yeah, I'm supposed to enter my passphrase. My passphrase is Betty, and yeah, it tells me that this file has been transferred, and tells me 100% the size of the file. So for us to be able to see that this is just our sandbox, let's go to our web server, which is this, and you see ls, you discover that we have a file here called zero transfer. Okay, that's just a practical section of how to transfer a file locally to your remote web servers. Okay, let's just do one other exercise, one more example. We said it's a scp disable strict key checking. To do that, you say strict key key host checking. Yeah, it's supposed to be host key, not key host. So host checking. We say let's disable that. No. What's the name of the file we want to copy? Let's, how about we copy our readme? So let's copy our readme. Let's copy our readme. Where is our identity file? Where is our private key located? We say our private key is located, for me, my private key is located in the home, under a hidden directory called .ssh. Yeah, whichever, yeah, I prefer to use this. So I say home.ssh, and it's in a file called school. I end my quotation. I will tell the computer my username. My username is Ubuntu, and my IP address is this. I think no. My IP address is what's the IP address? Okay, 52.91.146.146.23. So that's my IP address. Remember, the file we want to copy should go to the home directory in our web server. Alright, so when we run this, it tells me, okay, I think I missed a command there. Okay, it's just on the strict, I didn't put key, strict host key. Yeah, sorry. So I run the command again. And it asks me for my passphrase, Betty. So you can see that I've successfully transferred this file from my web from my terminal to my web server. I come back to my web server and I do an ls. You discover that I have my readme here too. So that's how you transfer files from locally to your remote servers. So in the nearest futures, you're going to be transferring file from your sandboxes into your web server, particularly for your Airbnb clones and the rest. So whatever files you need to transfer, that's the command for you to be able to do that. In continuation of task one, remember we're asked to install NGINX in our web servers. So I'll just leave my sandbox and go back to my web server. Yeah, you remember we did sudo app update and sudo app install. Now the next instruction says we should we should creatify that when we query our root, it's going to display hello world. So what we have done is that we've successfully installed Nginx in our web server one. Nginx should be listening to port 80. Yeah, I'm going to do that. And it said when we query our Nginx at root, it's supposed to get a request for us, and that request is supposed to print a string called hello world. So let's try and do that. Okay, so we are going to create a file in Nginx that's going to query our root to print out hello world. Okay, where's my web server? Right, it's here. So remember when I was speaking relating web servers to restaurants, there is a directory that is responsible for storing web pages and the rest. That directory is called the var directory, variable directory that stores variable data that change over time. That directory is called the variable directory, and under it you discover that um, we have so many directories in it. We have backup, cache, crash, lib, local, log, mail, opt, run, snap, spool, temporary directory, and this is our www dot. Yeah, so this is where your web's pages are being saved. Remember the chef in the restaurant. So this is like the chef in the restaurant that serves us web pages. So depending on the type of page it serves you. So let's go into that directory that's responsible for serving web pages. So we cd into w, and when you ls, you discover that you have html files here. So this is the directory that is responsible for serving you web pages. Remember when we say restaurant and a chef. So now that we're in our web server, which is the restaurant, let's locate the chef that is responsible for serving jollof rice, something like that. So this is the chef responsible for doing that, serving us html files. So when I now let's see the into html, you discover that we have some files in it, and the default file for nginx is this. So when we say default file, this is what I mean. So when you come to your browser, just get your IP address. Let's practicalize so that you can understand what I mean. So when you come to your browser and you just type in your IP, it's supposed to show you a default page. It says welcome to Nginx. So that's what I mean by a default page. So when you just open a browser, because you now have Nginx in your web browser, it's going to tell you welcome to Nginx. So you see this page. So we're supposed to make this page to display we're supposed to make this page so that you can display hello world. So to do that, now we'll carefully do that. So let me write out the instructions to do that. So for us to do that, we need to go back to our web server. Where are you now, web server? Okay, now this is what I'm going to do. So in this directory that is responsible for serving web pages, I'm just going to create a file. and put the hello world in it. So the command to do that is just to use echo, and what I want to put in the file is called capital H hello and capital WOLD with the exclamation, careful with the capitals and the upper cases, and I end my quotation. That's the string I want to put in it. Then I can put a pipe and say, okay, I want this content to be put into, so I use super privileges to do that. When you finish inserting this into the file, show me the content of it. So that's sudo t. Where am I taking this, putting this file, creating this file? I say I want to create it in the var directory, www, where web pages have been saved in the HTML directory. So that's what I want to do. Now I want to create a file for this. I will now create a file and maybe call it index.html. So this command is going to get this string and put it into this file. Now this is just the path to the file, HTML directory, www and var. So that just takes us to that place. The sudo, because I'm going to be using super privileges, and then this t, when you finish putting the content in the file, display it out for us to see. So you discover that it's saying hello world, and when you ls, you discover that you have two files there. So you have your index.html and your default index in the next page. Okay, the next thing you need to do is to do let's test our configuration files to see if they are okay. Next thing for you to do is just to do sudo nginx -t. So you test your configuration whether it's correct. So whatever we've done is correct. It says test is successful. Now what we're going to do is to, now that we've applied those changes, let's restart the nginx so that it can serve us the new page that we have written. To do that, you say sudo service nginx, I think, restart or reload. Yeah, let me run that command again. I like to use reload. So let's reload it. Now when we go to our browser, let's see if this works or if this will work. Okay, and this time around you're going to see this hello world. So you're going to see hello world. So this is how you save web pages using nginx. So whatever command you want to, whatever output you want to write, you just write it into the file and it will print it out for you. So when you finish, so what we've done here is just this. Okay, what we did is just to, we went into the restaurant, or yeah, the restaurant that is responsible for serving web pages. So we said that's the web server, and we came into the department that is responsible for serving you HTML files. And we said that department is in under the var directory www for web, world wide web, and we discovered that there's the HTML guy there that used to serve web pages. We went into it, cd into it, we listed it, and we saw that there's a default file here for the hello welcome to nginx and the rest. But now we want to create a new file, and we say you can use echo to do that. Just put in your string, whatever you want to output. Then we say we want to use sudo because we want to be the super user. Whatever the content is displays out for us, and we are creating this content in this part called var www.html. Then the name of the file is index.html. and we say hello world. When you list, you discover that we have a new file called index.html. Now let's test our configuration if what we have done has affected our nginx from running. So you do that by saying sudo nginx, and the next thing for you to it to display is saying test is successful. Then you can now do sudo service nginx restart to reload the page. And also, so when you make changes to your configuration, it's good practice that you reload your page or you restart the page so that your changes will be effected. So that's just what we did. Now we are going to write all the steps we have done into a script, and that's going to be our answer file. So let's go back to our sandbox. So go back to our sandbox, get the name of the file, back to my sandbox. So ls to see my files, and I will just paste. So I'll say vi and paste the name of my file. And now I'm going to write a script, but let me set numbers to see. Okay. Okay, the first thing we said is let's use call the interpreter to use. We say use bin environment bash. Okay, the next line is supposed to be a comment. So from what I would say I can say just this is just a comment. Yeah, say commands to install nginx on web server. Okay, now the next thing is for me to write all the commands I've used to install nginx. And remember, the first command we used was sudo to update our app packages. Sudo get update. The next one was sudo apt get install nginx. Yeah, remember that we should allow nginx to be listening to port 80. So port 80 is just your http. So port 80 is for http, port 22 is for ssh. I think port 8080 is for https. So you have different ports for different protocols. So let's use http protocol to do that. And for you to allow, you need to use your firewall to be able to allow all that. So we said sudo the name of our firewall is ufw, because that's like the default firewall for most Linux system. And we say you should allow nginx on to allow nginx, allow http through nginx. Okay, that's just what it means. All right. Okay, the next thing we did was to use the echo command. So we say echo what was the string we used? We say echo hello world. Echo hello world with an exclamation, and we said put it in a pipe, and we said sudo t into the var directory www and into the html and inside the file called index.html. Okay, yeah, I think I spelled html. Okay, the next thing we did was to test our script or our configuration, and we said it was sudo nginx -t just to test whether everything worked fine. And the next thing we did was to do sudo service nginx reload or restart, whatever you want to write. Yeah, I think reload. I'm cool with reload. Okay, So these are just the steps we took to achieve this. If you want to go further, you can just add comments to it and say install nginx. You can say test testing nginx. Yeah, this is just too much information, but just yeah, I'm just showing you testing nginx configuration. Yeah, just something like that. Okay, I can now save and exit. Because this is a script, I need to make it executable. And to do that is just to change the mode to allow users to execute this file called install nginx. And when you ls, discover that you have it as an executable file. Now let's try to git add one, git commit it, um then instructions to install nginx. Yeah, just a comment. All right, yeah, I can now git push. Yeah, I hope this works. So I'll just check whether all we did was correct. Everything works fine. All right, now because I wouldn't want this video to be too long, I'm going to break it into two parts. So this is where part one is going to end, and part two is going to start from yeah, so part two is going to start from task two, and it's basically going to be about how to set up a domain name, like a free domain name .tech. So let's just end the video here. I'll continue in the next part. And if you are not yet subscribed to the channel, it's on you because you're going to miss out on a whole lot of that. So just subscribe to the channel so that you can stay up to date with my videos.